Hello everyone and welcome to PostgreSQL Crash Course Day 3. This is your host Mohan and my WhatsApp number is listed here in case if you want to connect with me. So this is our day 3 and I just wanted to reiterate the point where we are covering the most of the theory sessions in the starting, and probably from the next week you will have the hands-on session. Then maybe it will be more interesting for you. But please try to understand that those concepts are really important if you want to know the basics of any database management system. So please utilize these days in learning and reading more about the engine and all the areas where we are covering in these slides. So with this, let's start our day. So yesterday we have already covered most of the parts. So uh, just to reiterate whatever we have covered. So we have covered about Postmaster. So it's a first process which will be encountered. So a user will connect to the Postmaster, and after the authentication authorization, it will create the process Postgres, and Postgres process will be connected to the shared buffer. Then, for example, if you have a read operations, all those the client will connect to the Postgres, and then this Postgres will check the data block in the shared buffer. If it is not found, then it will be fetched from the data files, and after that, the clients will get back the results. In case of write operations, maybe update or insert operation, if the data block is not found, again it will be fetched from the data files, and whatever updates or whatever modification we are doing, it will be recorded in the data block in the shared buffer. And once it is committed, it will be written to the wall files with the help of wall writer, and all the committed transaction will be stored in the wall buffer. So we have already seen the concept of wall write ahead logging yesterday. If you have not watched the video, please watch that. And after that, we have uh, checkpointer. So checkpointer basically runs every 5 minutes, and it will basically signals the BGWriter process to write all the dirty data from shared buffer to the data files, right? So uh, yeah, so this is what the work of checkpointer. So till this point we have covered yesterday. So now we will cover the another process that is called archiver. So archiver process. So what it will do basically. So in our SQL Server, we have a concept of a recovery model, right? Full recovery model and simple recovery model, right? So in case of uh, simple recovery model, what happens to the log files? It will be automatically overwritten or maybe reused. So it will automatically truncate the log files, right? So here, if the archiver process is enabled, it will basically take all the backups, or it will take all the uh, data whatever is in the wall file. So when this one wall file is full, when this archiver process runs, it will basically copy all the data from this wall files to the archiver log, and then that particular data which has been copied from the wall files, that particular space can be used by the further transactions. Okay, so this is similar thing which happen in our SQL Server as well. Whenever we are taking the log backup, all those area of file will be able to reuse the space. So this archiver process, it is very important to see if this is enabled, or this should be enabled in case of production system, because if it is not enabled, if in case this wall file gets full, it will be overwritten. All the data will be overwritten, and then we will not be able to provide the point in time recovery for the PostgreSQL database, right? So this is the concept of archiver. So consider this archive logs as .trn files, and this wall files, consider that as .ldf files in SQL Server, right? Okay, so after that we have clog buffer. Clog means commit log buffers. So what does this do? Basically, clog buffer will have all the information about the transaction status, whether it is getting rolled back, whether it is committed, or if it is in progress. So all the information will be written in the clog buffer. So in case of crash recovery, this clog buffer will be referred for the transaction which should be rolled back, or the transaction which can be rolled forward. So this information will be stored in the C log buffer. Then we have other buffers. So other buffers can be work memory buffer, temp buffer, and maintenance memory buffer. We have slide for this, so we'll discuss this later. After that, we have stats collector. So, or we can say statistics collector. So this statistics collector, what it will do? It will basically collect and reports all the information about the server activity, and it updates this information into the data dictionary of that particular, like data dictionary of the engine. So it collects information about how many times tables or indexes were referred or were accessed, what tables are accessed. So all those information will be collected by the stats collector. Now the next process is called auto vacuum launcher. So before understanding auto vacuum launcher, let's understand the concept of bloated table. So if you remember, I have told you about the versioning in PostgreSQL. Like it works in the concept of multi-version concurrency control, or MVCC, where it will have different versions of a row, right? So when there are a lot of update insert happening on the server, on the table, or on so all those tables will be bloated, right? Or it will have multiple rows, or we can say here tuples, which are outdated, version, which is not required. So it will create fragmentation if we have multiple update and inserts on tables. So this auto vacuum launcher process will perform the vacuuming operation, and during the vacuuming operation, all the bloated table or all the tuples which are outdated will be marked as for reads. So next time, whenever there is any data coming, that can use that particular space which were bloated earlier, right? So this is the auto vacuum launcher. So next we will discuss the details about each process. So first process is supervisor process, that is Postmaster, and it is the first process. We have already seen this. So this is the first process which gets started in PostgreSQL. It is act as a supervisor process, and it will basically start, it will monitor, it will start, and it will restart processes if they die. So once we will install PostgreSQL, I will show this in real time, like how this Postmaster process work. So Postmaster acts as a listener and receive new connection requests from clients. So whenever clients wants to connect to Postgres, it will first connect to Postmaster, and Postmaster is responsible for authentication and authorization. If you don't know about this, authentication means if you have the uh, legal ID, password, and IP. So if you have that, it will check and it will authenticate you. Authorization is the process where it will define what kind of action you can do in the database. So Postmaster process checks all those things. And Postmaster starts a new process called Postgres for each new connection, which we have already seen. And now we have a few more utility processes, that is BGWriter. So we have already seen this, that it will periodically write the dirty buffer to a data file. Okay, so uh, there are a few parameters which are related to this BGWriter process. So first one is BGWriter underscore delay. So the default value is 200 millisecond, and it can range from 10 millisecond to 10 second. Another one is BGWriter LRU max pages. LRU means least recent used. So this is by default 100 pages and range is 0 to 1000. It will define how many max pages it can write from buffer to the disk. Okay. And this is the BGWriter LRU multiplier. So again, LRU means least recently used. So the default value of this parameter is 2 pages, and it can range from 0 to 10. So let's understand the calculation, how it will calculate how many pages it should write. So Postgres engine by default automatically estimates the pages which needs to be written from the buffer to the disk. that is called the estimated needed buffer, and this will be multiplied by the BGWriter LRU multiplier. So let's understand with the example. For example, PostgreSQL just estimates that it needs to write 500 buffer, and if we have set the value of LRU multiplier to 2, so the total buffer which should be written is 1000 buffers. So once this value is calculated, it will be referenced with the max pages. So here in case of this example, it calculates that 1000 buffers should be written and the max page is also 1000. So it will write 1000 buffers from the buffer to the disk. Okay, for example, in case if this is 1000 and if this value comes as 1500 buffers, but still the limit is 1000, so it will write 1000 pages, 1000 buffers only. It will not write 1500 buffers, right? So it will be limit, the max limit will be defined by this BGWriter LRU max pages, right? So this is what it is written. If this BGWriter LRU max pages set to 1000, then in each round the background writer will attempt to write 1000 buffers, aligning with the maximum pages allowed. Okay, so now we have some other process that is called wall writer. So wall writer will basically write all the wall buffer to the wall file upon commit. Checkpointer, we have already discussed that this will invoke every 5 minutes by default, or there is one more parameter that is called max wall size. That is by default, it is 1 GB and maximum it can be 2 terabyte. So if this value, this max wall size value is exceeded, then it will also run this checkpoint. So the checkpointer sync all the buffers from the shared buffer area to the data files. Auto vacuum, we have already discussed. Auto vacuum is responsible to carry vacuum operations on the bloated tables if enabled. Then we have a stats collector. We have already discussed about it. It is responsible for collecting and reporting the information about the server activity, then update the information to the optimizer dictionary, PG catalog. We'll see this in detail later. Okay, log writer or logger, it will write the error message to the log files. So this is it for today, and tomorrow we will discuss some other process. Till then, please enjoy your learning. Have a nice day. Thank you.